Samuel. Welcome to today's tutorial. We are going to study light emitting diodes, then see how we can program and blink them using Arduino boards. Light emitting diodes are commonly known as LEDs. LEDs are mostly used for lighting and indication. In control, LEDs are used to indicate the current condition of a process. For example, the use of LED as the power indicator. The LED indicates that the power is flowing in a system when it's lighting. Then when it's off, it's an indication that there is no power flow into the system. The LEDs have a number of advantages in that they are smaller in size, they have a longer lifespan, and they have low power consumption. As a result, they have become the most popular source of light in many households. So in this example, we are going to connect two LEDs to Arduino board, then see how we can blink them in alternating fashion. So the components you need for this project includes an Arduino board. In this case, I'm using Arduino Uno, but you can use any other Arduino board that is available to you. USB cable for connecting the Arduino board to the PC in order to program it. Then your PC with Arduino internal development environment installed. A breadboard, one red LED, one green LED, two of 220 ohm resistors, and then male-to-male jumper wires. Yeah, so you can see the components. The Arduino board, the USB cable, resistors, jumper wires, a breadboard, and the LEDs. Once you have all these components with you, the next thing is to connect them. It's important to note the pin configuration of the LEDs. So the anode pin of the LED is the longer leg or the longer pin, while the cathode pin is the shorter leg of the LED. Having known the configuration, let's connect them. Connect the anode pin of the green LED to digital pin 2 of the Arduino board through a 220 ohm resistor, and the cathode pin of the green LED to one of the ground pins on the Arduino board. Let's now connect the red LED. So connect the anode pin of the red LED to Arduino digital pin 3 through a 220 ohm resistor, and the cathode pin of the red LED to one of the ground pins on the Arduino board. So the connection should be as the one shown on the setup below. Once you are through with the connection, open your Arduino IDE and type in the code below. So we have this code here. This one, let me copy it and paste it into my IDE. Yes, so I have my code here. Once you are through with the typing, the next thing is to power up your Arduino using the USB cable. Then go to Tools and select the right Arduino. In this case, I'm using Arduino Uno, so I'll select Arduino Genuino Uno. Then go back to Tools and select the right communication port. Which is connected to your Arduino. So in my case, I'll select this. This is where my Arduino board is connected. Then verify the code to see if the code is okay. Done compiling. This means that our code is okay. There is no any error with the code. So you should be able to see that as well on your end. The next thing is to upload the code. So we have this upload icon, so click the upload icon. Done uploading. So this means that my code is successfully uploaded into the Arduino board, and I should be able to see the LEDs blinking. So let's play the video. I'll play the video so that you can see what you expect. Yeah, you can see the two LEDs blinking in an alternating fashion. So the LEDs are blinking in an alternating fashion. So let's take a look at the hardware used in this project. We have the breadboard and the jumper cables. The jumper cable comes in three main types. You can have female to female, male to male, or male to female. In our case, we are using male to male jumper cables because they are the ones suitable for use with the breadboard. The LEDs are connected to Arduino digital pins through to 20 ohm resistors. We use resistors in order to limit the current as well as to allow for the voltage drop. This is because the Arduino digital pins output a maximum of 5 volts and 40 milliamperes, which is too high for the LEDs and can damage the LEDs if used directly without a resistor. So it's important to consider using resistors in your circuit. Next, let's go through the code. So you can see we start by declaring and initializing LED pin variables. So we have the first two lines declaring and initializing LED pin variables. So we have LED green variable and LED red variable. We declare LED green as integer type, then we initialize it to 2. So this 2 is the digital pin 2 of the Arduino, and 3 here is the digital pin 3 on the Arduino. Thus, the Arduino digital pin 2 has been assigned a variable name of LED green, while the Arduino digital pin 2 has been assigned the variable name of LED red. This means that anytime LED green and LED red variables are called, we are referring to Arduino digital pin 2 and 3 respectively. Next, we have the setup function, and inside the setup function we have the pin mode statement. The pin mode statement takes two arguments. The first argument is the Arduino pin number. In this case, our Arduino pin numbers have been given variable names LED green and LED red. Then the second argument is the state of the pin, and this can either be an input or output. So it is inside the brackets of the pin mode that we state whether the Arduino pin will be an output or an input. In our case, we make the pin mode an output since we are writing on the pin rather than reading from the pin. So we are outputting from the pin so as to light on or off the LED. Yes, so you can see the void setup function. Inside we have the pin modes. So the pin mode for LED green is output, LED red is also output. Then we have the void loop function. The loop function, I mean, so it's of void type, just as the setup function was also void, because we are not returning anything from the function. We have the loop function, and inside it we have digital write statements and delay statement. The digital write statement takes into parameters, whereby the first argument is the Arduino pin number, and the second argument can either be stated as low, so this one can either be stated as low, or either low or high. When set to high, you are sending out 5 volts to the pin. When set to low, it means that the pin becomes a ground, which is the same as sending 0 volts to the pin. Yes, so whenever the digital write is high, it means that our LED is receiving 5 volts. Then whenever the digital write is low, it means that the LED pin is receiving ground voltage, so 0 volts. Next, we have the delay function. You can see the delay function. So delay function, in delay we state the number of milliseconds. So in this case we have delay function with 1000 as a parameter. So this tells the Arduino to wait for 1000 milliseconds before executing the next statement. So the 1000 milliseconds are equivalent to 1 second. So this is equivalent to 1 second. Therefore, if we consider every statement inside the loop function of our program, it means that the program will start with the green LED on and the red LED off for 1 second, after which the green LED goes off while the red LED turns on for 1 second, and all this procedure of alternating the two LEDs goes on and on to infinity. Yeah, so as long as your LED, as long as your Arduino is being powered, this loop will continue running, and we'll have the LEDs lighting or blinking in an alternating manner. Thanks for watching. So see you in our next tutorial. Thank you.